For decades, astronomers have spoken in quiet tones of a theoretical instant, a moment so immense that it would turn our entire understanding of the very fabric of reality on its head. That moment is now theoretical no more. It's here. The James Webb Space Telescope, deployed to bring order to our observation of the universe, has instead brought something much more revolutionary. It has validated two historic findings, both with the power to overturn science. One sets aside the timeline of our universe, making essential cosmological presumptions untenable. The other proposes life off Earth as a fast-evolving likelihood rather than a distant probability. It's not a wild theory or guesswork. These findings are supported by Nobel Prize-winning physicists, by the world's most renowned astrobiologists, and by hard facts gathered from a machine that gazes deeper into space and time than anything to date. Collectively, they're coming together with one striking conclusion. We might already have caught sight of the first definite indications of life beyond Earth, and we've hardly even started deciphering what that implies. The proof has been mounting slowly, stealthily. Now, there is no question, and it's going to transform everything we ever believed we knew about who we are and where we come from. In the spring of 2024, the James Webb Space Telescope looked further into the void than ever before and took a picture of a galaxy designated SFUDS 7329. This galaxy is a staggering 13.6 billion light-years away, making it one of the oldest objects ever seen. But there's a catch, a huge one. According to present cosmological models, the universe itself is roughly 13.7 billion years old. That is, this galaxy was only 100 million years old after the Big Bang, an impossibly brief time frame for the complicated galaxy formation processes to take place. By everything we know, it shouldn't exist. The consequences are immense. Either our models of cosmic evolution are severely flawed, or we've horribly misunderstood the universe's timeline. More alarming is that this finding contradicts decades of reliable measurements, ranging from globular clusters to supernovas, and even NASA's WMAP satellite. All these formerly reliable estimates are now being questioned. Some researchers propose it's not simply an error or an outlier, it's a fundamental breakdown in our comprehension. As Nobel Prize winner David Gross succinctly put it, this isn't just a tension in the data. This is a cosmological crisis, and it's compelling physicists to rethink the very creation myth of the universe. Whereas cosmologists are racing to remap the universe's laws, astrobiologists are working quietly in a completely different arena, one that may redefine humanity's position in the universe for all time. Dr. Lisa Colton, perhaps the most esteemed astrobiologist, has gone on the record to state that the James Webb Space Telescope is likely to provide conclusive proof of life elsewhere in our universe. Her group is focusing on two targets, K218b, a planet with a potentially habitable atmosphere, and TRAPPIST-1 planets E and F, rocky planets with Earth-like features. What's amazing is that in the case of K218b, Webb has already found dimethyl sulfide or DMS, a molecule that, on Earth, is only created by marine life. This isn't some amorphous chemical signature. It's a precise biomarker, one with no known non-biological origin. And while the TRAPPIST-1 system keeps surprising scientists with its promise of supporting life, particularly considering the composition and stability of its atmospheres. According to Colton, Gerger, and other top researchers, all signs point to 2025 as the year we finally make the announcement, the year we officially acknowledge we're not alone. It's not a matter of if anymore. It's a matter of when, and that moment may be just months away. But the surprises don't end with planets or ancient galaxies. The James Webb Telescope has been photographing structures and phenomena that even push our most rudimentary assumptions regarding the operation of the universe. Among them is NGC 602, a place in the small Magellanic Cloud where Webb spotted the first brown dwarfs beyond the Milky Way. That's already a significant milestone by itself. More confounding, though, is star system HV Tau, in which Webb saw a companion star, nicknamed HVAC, actively building planets in a protoplanetary disk in a manner that defies existing models of stellar evolution. More astonishing is Galaxy Cluster Max J017.5, where a bubble of astonishingly youthful stars has been discovered startlingly near our own galaxy. Together, these results all point to a disturbing potential. Our picture of how stars form, galaxies come into being, and how time itself works as a cosmic scale could be fatally incorrect. For years, Astrophysicists assumed the more intensely they gazed deeper into space, the more they would confirm current theories. Instead, the opposite is occurring. The more evidence Webb collects, the more it exposes a universe that is unprecedented. A universe where time, matter, and even logic itself appear to act in otherworldly fashion. And now, two colossal scientific tales are unfolding concurrently, one tracking the breakdown of the default cosmological model, the other hurtling toward the confirmation of extraterrestrial life. Individually, either would be monumental. Conjoined, they herald a revolution in science. What's becoming more and more apparent is that the universe we believed we knew is more enigmatic and vibrant than anyone could have imagined. If Webb keeps making these types of revelations, we might soon be compelled to discard the Big Bang as we know it. We might have to accept that the universe is either older, younger, or something else altogether. And perhaps most radically, we'll have to embrace the idea that life is not a rare cosmic accident but a common thread woven into the very fabric of existence. The scientific community, once rigid in its paradigms, is starting to brace for these revelations. Because if only half of what Webb is demonstrating is real, then we're experiencing the break of day on a new epoch, not only a new era in science but one in civilization as well. We're not so much upgrading our models as retelling the tale of existence itself. And 2025 can be the year when the universe finally demands our attention. Maybe the most bewildering surprise of Webb's finds is a hint that sounds like science fiction become reality. That time itself may not be absolute throughout the universe. While scientists look farther out into space, they are observing galaxies that appear much older than their position in the chronology would lead them to believe. These galaxies have old stars and intricate structure, despite being in what should have been the turbulent early days of the universe. This shouldn't be possible. The effect has caused some theorists to suggest a radical new concept, that cosmic time isn't universal. What we measure as 13.7 billion years might only hold for our corner of the cosmos. Elsewhere, time may pass faster, slower, or even cyclically. It's a notion that rocks the foundations of physics, challenging the very assumptions of redshift data, expansion rates, and even the timeline of the Big Bang. If time itself is flexible, if it's not a single thread but a tangled web, then our entire framework for understanding the age, structure, and fate of the universe could be fundamentally wrong. And that means we're not just looking at strange galaxies, we're glimpsing alternative realities. Webb's ultra-deep field images have revealed something else, something truly unsettling. During gravitational lensing and light bending in the farthest corner of the universe, astronomers are seeing patterns that indicate the existence of mass well beyond what there is in our observable universe. These distortions are not matching any known structure. The mass needed to produce such gravitational warping just doesn't exist, unless it's something coming in from beyond our universe. This has provoked an ever more plausible and sinister theory. Perhaps we're observing remnants of another universe, cosmic echoes of a neighboring universe. Others physicists are considering whether our universe was not the first or only one. Perhaps these huge buildings are the ruins of a dead universe that failed to work or, more apocalyptically, one in which the Big Bang never took place at all. It's conjecture, sure, but the trends are ongoing. The evidence is piling up. If it's true, it would be that our universe isn't a closed book, but one page in an endless, boundless library of worlds. And Webb, by looking just a bit further, could be opening a door to something we were never meant to glimpse. While the scientific world starts to consider the very real possibility of extraterrestrial life, international institutions are quietly laying groundwork for a world that once was exclusively the province of science fiction. NASA has already developed extensive guidelines for astrobiological communication, including how to verify, disclose, and react to the discovery of alien life. The Vatican, which has long been interested in astrobiology, has already published spiritual guidelines on how to handle contact, while the United Nations is working on new guidelines to deal with the political and cultural implications of such a discovery. Private observatories and AI research facilities are working together on technologies to detect technosignatures, signs of advanced civilizations, like atmospheric anomalies, unexplained radio signals, or artificial satellite patterns. There is no countdown timer, no public declaration, but don't be fooled. Those in the lead are acting as if something is imminent. The discussions are no longer what if, but when. Even doubters are listening, because when governments, religions, and scientists converge in quiet readiness, it typically means the unthinkable is about to become reality. Maybe the most chilling news yet is Webb's serendipitous discovery of neutrino-driven anomalies around ancient stellar remains. Neutrinos are subatomic particles so evasive that their detection is akin to discovering a single drop of water in the ocean. And yet, Webb's sensors have been able to capture a recurring pattern of fluctuations, sequences that are mathematically patterned, some even mirroring prime number intervals. That's not random. Actually, prime number sequences have been theorized for years as possible signals of intelligent communication due to their rarity in mathematics. More chilling is the fact that these signals are coming from areas where no activity should be present: cold, dead remains of stars. Some scientists are starting to murmur a possibility so profound it sounds like fantasy. These could be the indicators of passive monitoring. Something somewhere may have left a trigger behind to hear